Welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, January 5th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. And of course we'll take a look at snow potential for the Sierra and surrounding mountains in the Northwest U.S. Let's get to work. As usual, we'll start looking at significant wave heights for the North Pacific Ocean, and we see a pretty calm pattern. Yeah, there's an area of 17-foot seas off the Pacific Northwest associated with low pressure in the northern Gulf of Alaska, but nothing is really expected to develop from this other than wind swell pushing into the U.S. West Coast. And otherwise, no significant class storms are forecast, or at least immediately developing over the North Pacific. First off, we'll take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough that is a dip in the jet, sort of like what's going on right here. That would help create a counterclockwise flow aloft in the atmosphere and also down at the ocean surface, and that is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have this kind of a mixed pattern. The jet is consolidated, pushing off Japan with winds to 150 knots. A little bit of a trough trying to organize here. Maybe that will evolve over the next couple of days. And then the jet continues over. Here's the date line, the international date line. It moves just a little bit east of there, somewhere north of Hawaii, and then the jet splits. Okay, you see the northern branch pushing into the Pacific Northwest, and that's the line where weather will be north of that, but not south of that. And down south of here, the jet also splits. But when you get these split patterns, you typically get high pressure in between. High pressure, of course, is not good for generating swell, at least not, real ground swell. It's more like wind swell. And that appears to be the theme for the coming week. So we'll put this into motion. Here we go. As we get into Monday, yes, the trough evolves pretty nice off the Krill Islands, being fed by 140 knot winds. That continues. The trough actually builds as we get into Tuesday, and even some into early Wednesday. It sort of pulses again, but then starts lifting northeast. So yes, we would expect low pressure there. But also notice this big split, high pressure, likely to be the common theme over the eastern Pacific. The jet diving down the coast, but not far enough off the coast to produce any surf, likely, and it's north of where the jet is, where the weather would be. So this looks pretty much like from Northern California northward. If there were weather potential, that's where it would be, at least as of Wednesday night. We get into Thursday. Same sort of pattern. Another trough starts trying to dig out here Thursday night off the Kurill Islands. Again, now the jet even lifts. The northern branch lifts even further north as we get into Friday off the U.S. West Coast. Most weather confined to, we'll say, Washington and northward. We're into Saturday now. We're almost a week out. Just the same pattern. Consolidated in the west. Super split in the east. Not looking very good. We get into Sunday. We're a week out now, and really just no change in the forecast. What's going on? Well, so here's the typical deal. We have wind energy making it off Japan, but then the wind energy actually splits, and that causes or weakens. That causes the jet to split. Why is that? Well, we spend a lot of time talking about the MJO, Madden-Julian oscillation, and we get to that part. We believe that's what's causing all this to happen. All right, let's go take a look down at the surface, though we suspect there will not be any particular surprises here. Here we are, surface level pressure, surface level winds, a little bit of a gale trying to organize here off the Kurill Islands. We know there is a trough there, so that is not surprising. Not a big gale, and then we know there's a split in the jet over here in the east, and sure enough, high pressure off the U.S. West Coast. No big surprise there either. All right, we get into Monday. We see the gale evolving nicely. What is that, 50 knot winds, maybe a little bit more off the Kurill Islands over a very small area. And this gale is not moving east at all. If anything, it's retrograding backwards towards the Kurill Islands. We get into Tuesday morning. North winds at 45, almost 50 knots. They're aimed pretty decently at Hawaii, so it seems likely that some sort of a, decent area of seas will evolve here, radiating towards Hawaii and somewhat towards the U.S. West Coast, but the system's a long ways away. Finally starts moving a little bit east, but it's more north and fades by Wednesday. A new gale pushes off Japan. We know there's another trough that's supposed to build there in the West Pacific. It does its thing. It actually moves a little bit more to the east, but again, the split point is like somewhere over in here. So odds are this will only make it to the split point and then get shunted off to the north, and that's exactly what we see happening. The gale lifts off to the north as on Thursday night there, and just starts weakening. A little bit of a system to form in the northern Gulf on Friday. Again, the jet pretty far to the north here. Gets a little bit of purchase on the ocean surface. We'll see what sort of seas evolve from that, but probably not a whole lot. High pressure holding in control. That's what's feeding strong trades over the Hawaiian Islands and likely north winds down the California coast. We're into Saturday, then things continue to sort of just muddle along. We're into 180 hours out, another gale trying to develop over the Kuril Islands, and it looks like it's getting shunt to the north, and that's about it. High pressure in control in the east. So, no obvious signs of some prolific storm pattern setting up. Next up, we take a look at significant wave heights. What is the effect of these winds on the ocean surface? Well, we know there's a gale supposed to be developing over here off the Kuril Islands. There it does. Now notice there's seas here. Most of them are either aimed north up into the Bering Sea or south at Japan, not doing anything until we get into, there we go, let's say Monday night, Tuesday. Then some fetch starts taking aim on Hawaii. There we go. 30, what is that? 36. We'll give it 35-foot seas here. Pretty good distance from Hawaii, but still that could make for some swell. And falling southeast, aimed reasonably well at the islands into Wednesday. A little bit of energy for the U.S. West Coast, but we're not expecting much. Next gale starts forming Wednesday night off Japan. 32-foot seas, and that's about it. That's as much, and it sort of pushes off to the east and then is going to lift north. It dies. Then one little system up in the northern Gulf with 30-foot seas on Friday, falling southeast, barely in the, we'll say, the central California swell window. Some swell should result from that as we get into the weekend, but probably a bunch of wind associated with it too. Then after that, we're looking, and really not a whole lot. So not an obvious prolific storm pattern, to say the least. So let's go take a look and see what effect all this is going to have on local winds. All right, on Sunday, let's get us out to, here we are, about 4 p.m. on Sunday, California time. North winds along the coast, 10, 15 knots, maybe a little bit more down Point Conception. Yep. Trades for the Hawaiian Islands, 15 knots, maybe 20 knots. Yeah, that seems about right. So we get into Monday, pretty much the same thing. Again, this is all driven by, here's high pressure right here. That gives us this fetch of easterly winds pushing over the Hawaiian Islands the whole way from California. Sure, it makes for wind swell along exposed east-facing shores, maybe wrapping into the North Shore. But, we want big storms up here, and we're not seeing that. Little low, pushing towards the California coast on Monday night. Not even generating 30-knot winds. No big deal there. Trades continue for Hawaii. We go into Wednesday. Northwest winds continue for North and Central California, 15 knots early, and up to 25 knots for Point Conception later. Strong, we'll call them nuking, east trades for the Hawaiian Islands, driven by this just dominant 1034 millibar high pressure system. Thursday, pretty much the same deal again. Gale develops in the northern Gulf. We saw that Friday. There we go. The winds may be breaking up a little bit on Friday along California. Trade's still hard for the Hawaiian Islands. Saturday, looks like the north wind machine is getting, oh, look at this, a 1040 millibar high. That's a very strong high pressure system. Backtracking or retrograding a little bit off the California coast. Maybe allow some weather to seep in, but probably not much. So we're into Saturday. There's your north winds again along California. Trades for Hawaii, it is a broken record. Sunday, just nuking north winds for the whole north and central California coast. Trades, lifting a little bit north from the Hawaiian Islands here, so maybe a bit of a break from the wind machine, only 10 knots from the east. So, basically, pretty windy for the foreseeable future. All right, let's take a look at precipitation potential for mainly California. We're looking for rain or snow. We'll take anything we can get. This evening, maybe some light showers up in Cape Mendocino, but high pressure. You can see it ridging into the coast. That pretty much shunts everything north of that line. Pacific Northwest, yes, they'll be active. So we're into Tuesday here. A little bit of rain for Northern California again. Maybe a dusting of snow for Tahoe into Wednesday morning. And then that's it. Again, the focus. You can see there's the high pressure. So whatever weather systems there are, they ridge over it, then fall down the coast. We need the high to either retrograde or disappear completely if you want to open up the storm door for California. Another maybe dusting of snow or rain Thursday night for Tahoe, but no further south. Here goes another good solid system pushing in Friday night for the Pacific Northwest. Doesn't make it even to Tahoe. Yeah, just barely. A dribble of snow Saturday during the day. That fades out. We're into Sunday. Same deal again. Pacific Northwest getting hammered. Doesn't even make it to Tahoe. And that's a week out. So, not a whole lot of snow production looks possible for at least the California area. But Pacific Northwest and inland from there, probably not doing too bad. In fact, we'll do a real quick loop here. All right, Tahoe's right there. San Francisco there. There's the Oregon-California border. Keep your eyes up in here. That's where all the action is. We'll just plow through this. This is the GFS model, so it goes out 10 days. You can see where the snow mainly is a little bit down into Tahoe there. Tuesday night, Wednesday, but not much. Another little dribble maybe Thursday afternoon. But again, Pacific Northwest gets all the action. Here's another little dribble on Saturday. That fades out. And then another one coming in on Monday, early Monday. Oh, maybe a little bit of snow there for Tahoe on Monday. That's better than previous runs of the model. And then where are we? We're out when a week from Wednesday, end of the model, things dry out. Let's look at some specific locations. Squaw Valley for the next week. Okay, we'll give it 6 inches and maybe 14 inches total if you go out the full 10 days. Don't know that I'd believe the models in that. Snow levels to the top of the mountain right there in the next couple of days, falling down below the base, coming back up, and then maybe a little bit cooler a week to 10 days out. And wind forecast, we'll do a quick gander here. Pretty windy up top once you get past January 10th. So even if there was snow, Upper Mountain probably shut down. A quick look at Mammoth, virtually no snow. Snow level, mid-mountain, and in the worst cases scenario, they're higher, not so bad. Winds, still pretty much a factor. So to really see the effect of the jet stream and the snow levels and what's going on, we're looking at Whistler up there in British Columbia. Now they're forecast to get, what is that, about 69 inches of snow over the next week. This is the base of, so Whistler has a very low base, like 2,000 feet. The summit up at about 7,500 feet. That's like 5,400 feet of vertical there. Yeah, a little bit of rain maybe on January 7th or so to mid-mountain. But after that, looking pretty good. Wind, yeah, it's windy, but not horrible. So it looks like if you want to go on a ski trip, Whistler or somewhere in the Pacific Northwest, that area is probably the best call. So let's go take a look long-term. What's going on with the Madden-Julian Oscillation, the MJO, and of course the El Nino Southern Oscillation, El Nino La Nina. As usual, we like to look at winds across the equatorial Pacific. This is the East Pacific here. This is the West Pacific. That is the equator there. The date line running right there. That's New Guinea right there. The area we're really interested in here is in the West Pacific, a thing we call the Kelvin wave generation area. When the active phase of the MJO passes over this area right here, from 5 degrees north to south, from 170 west over the whole way to 135 east. If you get west anomalies in here, that takes warm water that's in this area, starts pushing it off to the east. It travels under the equator the whole way across the Pacific, and then if it's strong enough, can erupt off of Ecuador, and that is called a Kelvin wave. hence the Kelvin wave generation area. And if you have successive Kelvin waves, they can eventually create or at least support the formation of El Nino. All right, but we're not looking at El Nino. We're looking at the MJO. The MJO is like a mini version of El Nino. It only lasts for 3 weeks, but it can create westerly anomalies here and create a Kelvin wave. All right, so the arrows is all we're looking at. We see easterly winds, pretty solid, but not super strong over the East Pacific, continuing over the Central Pacific, over the dateline, and into the Kelvin wave generation area, maybe weaker south of the equator. No obvious signs of the active phase of the MJO here. We look at anomalies then. Differences from normal for this time of year. Are these easterly anomalies stronger or weaker than normal? We actually see they're weaker than normal because the arrows are pointing out of the west. Okay, well, that's kind of a good thing. And then we continue over the dateline. Yeah, anomalies out of the west. And in the Kelvin wave generation area, normal to slightly out of the west. So eyeballing this and kind of knowing what's going on, it sort of looks like the active phase of the MJO has already done its thing over here in the Kelvin wave generation area, and it's fading and moving to the east over the East Pacific and pretty much moving out of the picture. And then our guess would be that the inactive phase of the MJO is right behind. That's the way it works. You get the active phase for 3 or 4 weeks over the Pacific, then the inactive phase comes in, unless you're in El Nino, and then it just seems like it's a perpetual active phase of the MJO. Or, conversely, if you're in La Nina, then it seems like you're in a perpetual inactive phase of the MJO. And of course, the MJO, when in the active state, feeds energy to the jet stream, helps support storm formation. When in the inactive phase, does the exact same thing. It steals energy from the jet stream. Now remember what the jet stream charts look like? Kind of okay over in the West Pacific and the East. The jet was weak. It was split. That looks like the inactive phase of the MJO. All right, so let's dig and see if we can find some evidence for or against that theory. Let's do a quick look at CDAS 850 millibar wind anomalies. Differences from normal for this time of year. Now, this is the same chart like daily increments. So there's South America. The equator is right at 0 degrees right there. We're looking for the Kelvin wave generation area. Well, dateline's right there. Kelvin wave generation area basically right there. We're looking for the color orange and arrows coming from the west. So on December 30th, yeah, it looked like there's our active phase of the MJO moving off to the east and weakening. It kind of goes in spurts. It's really this whole area here. And slowly pushing in to Central America as of January 3rd. All right, so here's past performance and the forecast. This is the whole planet on one chart. Okay, but there's the date line running right up the middle of the chart. The Pacific starts about somewhere right here, 130, 135 east. Goes the whole way over to like 80 west here. But the Kelvin wave generation area is from here to about here. And you just draw a line straight up both these spots. You can see Kelvin wave generation area roughly here. The oranges are westerly anomalies. There was the active phase of the MJO, if there ever was one, right there. Pretty solid from mid-December through till about today. And then what do we see below that for the coming week? Well, we see easterly anomalies. They're almost out of the Kelvin wave generation area, just over in the dateline region. But you can see, if I were to draw what I think is the inactive phase of the MJO, it would be like this. In the West Pacific today, moving to the dateline, and then holding in pretty strong a week from now. This is only 1 week. So let's go look a little bit further out. So now let's look 2 weeks out. This is outgoing long-wave radiation. Not looking at wind anomalies. This is rainfall potential, but it's basically you can use the same thing. Yellows are a lot of sunlight reflectivity off the ocean surface, meaning no clouds, meaning the inactive phase, the MJO. So we see the inactive phase. There's so there's New Guinea. There's the date line right there. There's the equator, South America, of course. So Kelvin wave generation area right here. Looks like a weak inactive phase today. And according to the statistic model, it's supposed to be building on the dateline 5 days from now, getting pretty strong 10 days from now, and even stronger 15 days from now, but moving out of the Kelvin wave generation area. The Kelvin wave generation area cuts off like right about there. And here is the active phase building in the Indian Ocean over the maritime continent, easing into the West Pacific at day 10, and then pretty much getting into the West Pacific at day 15. Again, this per the statistic model. And then here's the dynamic model, the GEFS model, basically painting the exact same picture. Here we are. There's 15 days out from the statistic, 15 days out from the dynamic. Only the dynamic model suggests the inactive phase fading more, and the active phase, maybe not quite as strong as the statistic, but basically pretty close. So from our perspective, we'd say maybe about 11 days from now, that's when the jet stream will start healing, more energy will be imparted to it, and then maybe the storm machine will wake up. And then it's not till the active phase starts moving over into here that the split off California and north of Hawaii and the jet stream will heal. And then that would be when maybe precipitation will move more cleanly into California and storms will start pushing into the Gulf of Alaska. Let's take a look at phase diagram charts. Another way to get a sense of what the MJO is doing. The circle here, so you're looking down, let's say on the North Pole, and the MJO travels from west to east, both the active and the inactive phases, from west to east, from the Indian Ocean over the maritime continent, across the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. All right, the heavy dot is where the active phase is right now. So in the Indian Ocean, the further away from the circle it is, the stronger it is. So extremely weak, it's inside the circle. Then can't tell, but there's 3 different versions of the statistic model here. 2 of them say the active phase very weak moving to the West Pacific, but one of the runs says pretty strong and moving to the West Pacific 2 weeks out. The dynamic model sort of tracks with that one, saying active phase getting very strong over the maritime continent, moving into the West Pacific, and then sort of crashing, but still not bad. I mean, we'll call it modest strength 2 weeks from now. All right, so pretty good correlation between all the models. Let's take a look at the CFS model, all right? Again, this is wind anomalies, 850 millibar wind anomalies, whole planet on one chart. Kelvin wave generation area starts from here to about here. You go right up here. All right, here's where we are today. So we see here's our current westerly anomalies on the date line. There's the date line right there. But easterly anomalies encroaching in a week from now, moving into the core of the Kelvin wave generation area. The dotted contour is the inactive phase of the MJO. So inactive phase, it's already been building for the past couple of days, in the far west Kelvin wave generation area. And is to make its way through the Kelvin wave generation area and be gone about 10 days from now. All right, that's exactly what the other models were saying. But even better, here we go, active phase of the MJO setting up, we'll say about January 15th, and pretty strong. I mean, look at how strong the westerly anomalies are forecast here on the date line and holding through at least February 1st. So if you believe the models, one, and you have work that you got to do and stuff you got to take care of, this is the perfect time starting right now through about the next 8 to 9 days. Go take care of your business, because once this guy, if he forms, happens, then we'll be in a much better position. More energy will be transported into the jet. The storm track should improve. We should start getting surf. And then later in this active phase, as it starts moving, California's way over here, and Oregon, the coast, when you start seeing westerly anomalies build in over here, that's when the snow machine typically starts up. So you've got, till the end of January till that happens. But the surf component of this would start much earlier. All right, and then let's go look even further out. This is a 3-month version of the CFS model. All right, here we are today. Oh, Kelvin wave generation area starts somewhere right along in there and goes to about there. Here we are right today. Easterly anomalies in the Kelvin wave generation area, just getting ready to set up maybe tomorrow. Yep, expected to continue to about January 13th, and then we have a very significant westerly wind burst event forecast starting mid-January into mid-February. Let's overlay the MJO. There you go. There's your active phase of the MJO. with 1, 2, 3 contours. Pretty solid. Here's our inactive phase we got to weather through first, but only for a week, 10 days, something like that. Not too bad. The problem is after the active phase, the MJO and whatever snow and surf we get from that, then we go into a pretty significant inactive phase. And this has just happened today. The strength of this is a little bit stronger than what was previously forecast. Now, the point to look at here, the blues here, this has been this big blocking easterly wind event thing that's been going on in the Indian Ocean. We believe this is tied to the wildfires that have been occurring in Australia, breaking down the monsoon season and just making life very miserable for people there. The good news from this model is that with this coming, so you have your coming active phase and then the inactive phase after that, east anomalies are supposed to basically bleed out of the Indian Ocean and then dissipate after that. That would be the end of the blocking pattern. Maybe there'll be some relief for Australia then, and then another active phase after that starting, when is that, about mid-February and continuing out till late March. Again, don't believe a model this far out, and don't even believe that this is going to happen, but it's kind of been toggling on and off on the models. It's here for a couple days, it disappears, then reappears. Maybe getting rid of this blocking pattern will sort of open up the floodgates for the whole Pacific Ocean as well. The problem is by the time it's all over, we're into the middle of March and winter's over, and then, well, yeah, maybe you'll get one last little hurrah in spring and that'll be it. And then the low pass filter. This is sort of the solid contour here. We've talked about this before. This is a low pressure bias centered right over the date line. We're at 3 contours. Not much of a third contour, and it's supposed to be gone in 2 or 3 days. But the second contour, so this is sort of like a propensity for a weak El Nino-ish kind of situation, but that's supposed to fade out in mid-March, and then we're down to almost neutral. This high pressure bias, the dotted contour, is over the Indian Ocean. We suspect that will start fading as well. And then the question is, where are we going to be next summer? Unknown quite yet. All right, enough of the MJO. Let's start looking at El Nino. We're going even further out into the future. What's going to happen next summer? All right, so first off, we got to look at the ocean, not surface temperatures, subsurface. This is the West Pacific here. This is the East Pacific here. This is data from the TAO buoy array, series of buoys strung across the equator, the whole way from Ecuador over to, north of New Guinea, used for monitoring El Nino, but we can also sort of monitor the MJO with it and other things. So first off, we want to look at subsurface temperature profiles. We're looking for Kelvin waves, right? If you got the Kelvin wave generation area right here, and you have westerly anomalies, it'll take this 30 degrees centigrade, multiply that times 1.8 to get Fahrenheit temperatures. If you get westerly anomalies blowing, it'll take, during the active phase, the MJ will take this warm water, start pushing it off to the east in a ball. All right, so right now, the 30-degree isotherm is at 180. It actually had backtracked like 170, even behind that earlier this week. Coming back, snapping back to the east, that's kind of a good thing. The 29-degree isotherm, same deal, pushing off to the east. Same deal with the 28-degree isotherm. It suggests warm water is pushing to the east. The 24-degree isotherm is at 110. It was over like 105 last week, I think, or 103. Backtracking a little. Okay, so that suggests maybe there was warm water here that's backtracking, but over here there's more warm water moving forward. Let's go take a look at anomalies. Differences from normal for this time of year. Sure enough, plus 3 degrees centigrade temperatures under the date line. This is Kelvin wave number 6, I think it is. 6th in the past, I don't know, year and a half, something like that. And it's actually, there's this pocket here, and this pocket's new too. We think it's actually part of this Kelvin wave. It's all seeping off. The leading edge is like, where are we here? Yeah, about 120 west. There was another Kelvin wave number 5 over here. It's not showing on this chart, but we go down to this higher res model. It lags time-wise, but we think the model has a little bit better handle on what's going on. Here's Kelvin wave number 6. You see, still pushing out of the maritime continent into the West Pacific. due to continued west anomalies and active phases of the MJO, the one that happened in December. And this was actually created from one prior to that, so it's like 2 active phases are feeding this one. Leading edge at about 125 west, pretty much south of California. And here's Kelvin wave number 5, all but gone, but still pushing inland over Ecuador, creating some warming there. Sea level anomaly chart, just another way of sort of confirming where warm water is or where it is not. So this is JSON-2 satellite data. Basically, you strip out all the waves, you strip out the wind waves, you strip out the tides. We see a plus 5 centimeter bump on the ocean surface from this is the equator. That's the date line. So some northeast of New Guinea. There's New Guinea, almost the whole way into Central America. Warm water at depth. A Kelvin wave expands, creates a little bump on the ocean surface. That's what we see here. So just more confirmation that Kelvin wave number 6, I think we said, is large, in place, and pushing off to the east. Upper ocean heat anomalies, upper 300 meters, the ocean surface, sort of a histogram of past and current Kelvin waves in flight. So here is the West Pacific here. Here's the East Pacific here. Times, February 2018. This is warm water, the reds. Westerly wind burst occurred here. Active phase of the MJO back in February 2018. Started taking warm water, pushing it across the Pacific under the equator. It erupted, 4 months later in May off of Ecuador. Then 2 more westerly wind bursts, active phases of the MJO, created mini Kelvin waves, but they got stalled out like south of California. Didn't make it into Ecuador. There was easterly anomalies and upwelling off of the Central American coast during that time. But then magically, as we got into the fall in September, another westerly wind burst, another active phase of the MJO, created a Kelvin wave, started again September, and just now in December, it is reaching Ecuador, and we'll take a look at some of the details around that in a moment. And then here's our current Kelvin wave number 7 setting up due to the active phase of the MJO in the December and late November timeframe, and it's starting to make its way across the Pacific as well. So we take a look at sea surface temperature anomalies, differences from normal for this time of year. We see light warming off of Peru. That's good. Normally it's cold here. A little bit of warming off of Chile as well. Certainly there's Ecuador there. And then cruising along off to the west, off the equator, there's been this persistent cool pool down here. It's not really helping, not really hurting. And then broader warming from a point, we'll say off from the equivalent, there's mainland Mexico. From there on over to the date line. All right. So this is Kelvin wave number 6 erupting here. You see it's doing something, but it's not huge. There's not some giant impact. If we were in El Nino, this whole area in here should be red. But this is sort of like a Modoki El Nino, and it's not even that. It's just very weak warming. The official El Nino monitoring region starts out at 120 west, 5 degrees north and south of the equator, goes out past the end of the frame here. This is what they call the Nino 1.2 region, so you have a little warming, a lot of cooling in this area. This is always a mixed bag, very noisy in terms. So what happens is the trades take warm water here, push it off along the equator, and this is a more stable region, and supposedly if you have warm water out here, that creates evaporation feeds energy up into the jet stream. If the warming builds close enough here, it starts actually pushing the jet stream cleaner into California and creates your typical El Nino impacts during winter months, like right around this time of year. But clearly that's not the case this go around. The 7-day temperature trend, sea surface temperature trend as of January 4th. It's pretty obvious here. You can see warming all off of southern, central America on the equator, pushing out to about a point south of Hawaii. There's Hawaii there. So the Nino 1.2 region trying to warm. The Nino 3.4 region starts, it's like right in here. Yeah, it's a mixture of warming. I wouldn't say cooling, but just stable. Pretty much neutral. This area is trying to get warm, but there's only a 7-day trend too, and we need months and months of this if you were to get El Nino. We don't think that is happening. And then actual sea surface temperatures anomalies for this time of year. You see, light warming along Peru and Chile and Ecuador and all of Central America and along the equator. So we're not colder than normal. And actually, this little area here has been steadily warming right in here. Again, it's not like if you were in El Nino, this whole triangle here should be cooking hot. It's not. Just light, quarter of a degree warming or something. But that's way better than La Nina, where all this would be colder than normal, and markedly so. In fact, it was that way this summer, and we're going into La Nina, and now we're looking at it and go, we're pretty much normal. If anything, biased a little bit warm. Remember the low-pressure bias thing we saw that was over the dateline region on one of the previous charts? That is probably contributing to this just generally light warming trend. Sea surface temperature trend in the Nino 1.2 region, right off of Chile, Ecuador, and Peru there. Today's value as neutral as you can get. Minus 0.010. Was that a hundredth of a degree below normal? But you can sort of eyeball the trend here. Yeah, hovering right around zero since November. Better than it was, though. It's colder than normal, even in the fall. And we think that is what's contributing. So let's talk a little bit about this. There's been swells this winter. The last swell, heavily hyped. Complete blown out mess on Maui, blown out mess in California, just choppy, ugly. And that's really been the theme so far this entire winter. We think that is due to, of course, it's being driven by high pressure in the Gulf of Alaska, but we think that is due to that cool water that set up this summer in the Nino 1.2 region. There's the evidence of it. And cool water typically supports high pressure. It's an absence of evaporation. So, if you don't have rising air, you have sinking air, and that's what high pressure is all about. And we think that's what's been driving all the north winds, and it's kind of going to be the theme for probably a good part of the winter, if not the whole winter. Other than that, the Nino 3.4 region, the official El Nino monitoring region, temperatures today 0.373 above normal, so a little bit over a third of a degree above normal. And the trend has been toggling somewhere between 0.2 and 0.4 of a degree since October, something like that, and actually a little bit longer. Not El Nino, got to be half a degree or more for 5 consecutive months. We're nowhere near there, but we're biased on the warm side, better than being down here in the cool side in La Nina. But, when you're in the neutral zone, it is what it is. It's nothing epic, and that's where we're at. So what does the atmosphere think we're doing? Are we in El Nino, La Nina? Well, you look at the difference of pressure between Darwin, Australia, and Tahiti here, and you can get an index. If the index is positive, like today, it's plus 18.52. That suggests the inactive phase of the MJO. Now, not one day. It has to be days on end. As you can see, just January 3rd, we were negative, and we'd been negative for like 20 days prior to that. We were definitely when it's negative, it's the active phase of the MJO. Okay. Definitely, we were in the active phase. We think we're moving to the inactive phase. All the data supports it with easterly anomalies forecast setting up for the next week and a half or 2 weeks. Okay, no big surprise there. The 30-day average, that's a better way of telling where you're going right now. We're at minus 7.40, so that would say the active phase of the MJO. Just looking back, it's been, no different than what it, if anything, it's a little lower than what it's been. Okay, so we're kind of neutral. We expect this to start rising, though, as the inactive phase sets up. The 90-day average, if it goes deeply negative and stays there, like down at minus 15, then you're in El Nino. If it goes positive and stays there, then you're in La Nina. We're at minus 6.28, so no obvious signs of moving to La Nina, but clearly no signs of moving into El Nino. The same thing we've been talking about for months now, just neutral, biased, slightly El Nino-ish like, but not enough. Just kind of neutral, biased towards El Nino. The long-term forecast for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region. Right, so like we said, this summer, June, July, August, you can see temperatures were negative, not horribly negative, minus 0.3 of a degree. Then as we got into fall, they kind of bounced back and went positive 0.3 of a degree. supposedly. And as of January right now, we're supposed to be at, per the model, like 0.7 degree above normal, but we're really at like down about half of that. So this is a bit overhyped. Anyway, the model suggests that we will continue biased slightly warm, probably like in the pattern we're in through the spring. And then temperatures are supposed to start going negative to minus 0.7 in September time frame. That is, who knows, that's like moving into La Nina territory. Will we go there, or will it just be a dip like this, like a summertime dip, and then correct as we get into the fall? Who knows? But at a minimum, it looks like we're neutral, biased, warm. We're going to probably do some sort of a mini crash in the summer, and then who knows where we go to next winter. But certainly no clear signs of El Nino, no clear signs of La Nina either, at least for the next year. So let's do a quick recap here. Right now, not a whole lot going on in the Pacific. High pressure is supposed to take over the Gulf of Alaska due to a very split jet stream in the East Pacific. That will likely make for strong trades for Hawaii. North winds and wind swell along the California coast, not our preferred option for this time of year. We want long period ground swell. Well, we're not getting it. But we do know the culprit, and that is the inactive phase of the MJO. And even better news, it's supposed to be short-lived. 2 weeks, take care of business, we're out of there. Active phase returns, and supposedly pretty strong. We'll probably have a pretty good run of surf during that window, and then maybe some snow as well. And after that, then back to the inactive phase. We're in a neutral pattern. Long term is what it looked like. So we get the active-inactive swing, pretty much, what you'd expect from one extreme to the other. And that appears to be the trend, at least going the whole way into probably next summer or so. After that, it's a real unknown. Supposedly data-wise, the big east anomaly blocking pattern in the Indian Ocean is supposed to let up, be out of here as we get into March. Then maybe we'll really fall into a more normal kind of pattern. But for this winter, it seems like we got one big sweet spot left, and that's from mid-January into mid-February, and then maybe a lesser one as we get into late March sort of thing. And then after that, who knows? So the moral of the story is, get what you can get when you get it. When there's swell, don't make excuses, go surfing. When there's snow, don't make excuses, go skiing. And get what you can and be happy for it. All right, so that's it for this week. We'll do it again next week, same time, same channel. If you like the video, of course, hit the like button, leave us some comments. We always try to respond. And thanks for taking your time and watch the video. We really appreciate it. We'll see you next week. All right, enjoy. Be safe. Thank you.